the topic shift register. So, shift registers are built, implemented using set of flip-flops. So, we already know that flip-flops are the memory elements that store only one bit of data. So, flip-flops store one bit of binary information, either 0 or 1. So, flip-flops are referred as single bit register. They store one bit means they register one bit. So, single bit register, the flip-flops are referred as single bit registers. If at all we want to store more than one bit, more bits of data are to be stored, then we have to use those many number of flip-flops. We have to use many number of flip-flops. As many bits are to be stored, those many number of flip-flops are used. So, what is this register? Register is a set of flip-flops used to store binary data. Set of binary bits are to be stored using the set of flip-flops, and to that set we refer by the name of register. And these registers that store set of binary bits, they are capable of shifting the stored binary information either to left or to right. That is why they are referred by the name shift register. Whatever bits are stored in various flip-flops, they can be shifted in right or left direction. That's why they are referred as shift registers. And that's why finally we can say a shift register consisting of chain of flip-flops, set of flip-flops connected in cascade. Cascade means series. So output of one is connected to the input of next flip-flop. Output of one flip-flop is connected to the input of next flip-flop. So such shift register, which is having the capability to store 4 bits, we shall just discuss now. So 4-bit shift register, they employ 4 number of flip-flops. 4 flip-flops are used, and each of these flip-flops are D flip-flops. We know D flip-flops are delay flip-flops. So what is going to happen? Whatever is fed at the input, the D input, that appears at the output after 1 clock pulse delay. So this is the functionality of D flip-flop. So it is going to use such 4 number of D flip-flops, and this shift register, it shifts its contents to every negative edge of the clock. This every flip-flop is a negative edge triggered flip-flop. During every negative edge, the input appears at the output. The output is being shifted to the next stage. So first, to understand its working, we shall assume the initial state of the register. Means the initial state is nothing but the outputs of each flip-flop. The outputs are Q0 of first flip-flop, next flip-flop Q1, next is Q1, Q2, Q3. So the outputs are Q0, Q1, Q2, Q3. So this Q0, Q1, Q2, Q3 is equal to, let us assume that Q0 is A0, and then Q1 is 0, Q2 is 0, and the Q3 is also 0. So initially only the first flip-flop has got A0. All other flip-flops are at 0 states. Now we shall feed at the input the sequence A0, A1, A2, A3. So in the beginning, D0 appears, D0 is going to take the input A0, and while D1, which is connected to Q0, and where D2, which is connected to Q1, and D3, which is connected to Q2, all are going to be 0, 0, 0, 0. Only D0 is A0, D1 is 0, D2 is 0, and D3 is 0. What is the connection you are seeing? D1 is equal to Q0. means output of one flip-flop is connected to input of another. Similarly, output of this is connected, Q1 is connected to input D2. Output Q2 is connected to Q3. So initially what they say, for after first pulse, the A0 that is here, it comes over here. So the D0 is going to take, the D0 is going to take A0, whereas D1, D2, D3 will be at the state of 0. So after second pulse, what is going to happen? The next data in the sequence after A0, A1 is fed to D0. And this D0, earlier whatever D0 was having A0 is appearing at the output. That becomes the input of the next one. So it is after first clock pulse, second clock pulse, we are going to have Q0, Q1, Q2, Q3. Q0 is equal to A1, then this is A2 and 0, 0. This is how we are going to have the output. Next is after third clock pulse. After one more clock pulse, here are the clock pulse. After third clock pulse, we are going to have Q0 equal to A2. A2 is the next input. Earlier A1 was there, it is shifted to Q1. Next, earlier A0 is shifted to the output Q2. So, we are going to have A2, A1, A0, A0 and 0. So, after fourth clock pulse, Q0, Q1, Q2, Q3 will be equal to A3 comes at Q0, A2 goes to Q1, A1 goes to Q2, and lastly A0 comes to this one. And the Q0 is connected to B3, Q1 is connected to B2. So B0, B1, B2, B3 are connected to the outputs of the 4 flip-flops. So we are going to have read from left to right, B3, B2, B1, B0 are the various states of the resistors, and we are going to read these parallelly after fourth clock pulse. That is how to attain the position, whatever the input sequence this we have fed, they are going to appear in the manner A3, A2, A1, A0. A3, A2, A1, A0. And this A3, A2, A1, A0 is nothing but this one. It is read in parallel. That is why this type of resistor is referred as serial in, parallel out shift resistor. So the input is fed one after another, but output is read, all these outputs are read in parallel. That's why the name serial in, parallel out shift resistor.